All right, good evening, everybody. Like it says here, my name is Reinier. I would like to talk about LoRa, a network that we're building in our community in Temecula. Here you go. So this is a picture of me installing sensors in an orchard. I've been living in Temecula since last year. I own a small vineyard. It's kind of between a commercial vineyard and a hobby vineyard. It's too large to manage by myself and too small to make it my job. So it's kind of like in the middle. I started Vinduino as a project, and I submitted it to Hackaday, as Jasmine was telling. And it basically was a project started for myself. How do I manage irrigation in my vineyard? And then it turned out into an open source project, and now I'm the CEO of my own company running that. And thanks to Hackaday and the Hackaday prize, I got the seed money to get started on that. And then you see some prizes. If you want to reach out to me after the presentation and you can get a hold of me, here's my email address and also my phone number. Feel free to reach out anytime. Well, not at night, of course, but. So what is LoRa? That's basically what I wanted to discuss about, because we started with irrigation, and the need arose to have a wireless technology that can transport sensor data over a long distance. And as we are using battery-operated sensors, we want to do that in a very power-efficient way. And when I got started in 2015 looking into this, I started with a handheld reader. So I had to walk around and then connect the wires of every sensor and take a reading and just go on and on. Then I thought, well, that's not a very efficient way of getting data from my vineyard. Can I do it wirelessly? I made a prototype with Wi-Fi, but the range of Wi-Fi was just not enough to get where I wanted. I got to the first row of the vineyard, and that was about all the range I could get. And then with LoRa, I can get even further. So we get, in principle, about 5 to 10 miles range of and then run off a battery for more than a year, which is kind of incredible if you think about it. Anyway, so this technology allows for low energy. It's low speed. It's not Wi-Fi. You cannot do over-the-air firmware updates. Yeah, you can. There's talk about it, but I don't recommend it. And it's suitable for battery-operated devices. So small data packets. The typical fair use policy is that you use 30 seconds airtime per day. And if you have a typical half-a-second transmission time, then you can calculate how often you can go online with this technology. It's a star topology, so it's not that the nodes talk to one another and pass on the message. Every node talks directly to the gateway. So that's basically also the topology. And the way it works is that the gateway has multiple channels. In the US, you have 64 channels. In Europe, you have 8 channels. But the nodes can switch channels, and that means that a lot of stations can share the same airspace. So a typical gateway can support thousands of nodes. And that means that you can use it in a dense populated area like a metropolitan area like LA, if you want to build a smart city. That can, one gateway, if it's placed high enough and it has enough range, it can support like thousands and thousands of nodes. So in Temecula, we don't have that kind of nodes, but we like the range. And it also means that nodes interfering with each other is not happening with this technology. We use unlicensed frequency bands. It means that you don't need a license or anything. It's like Wi-Fi. You can transmit in these bands with FCC-approved equipment. And I don't know if you're a ham radio operator or you want to know about the modulation that is being used, but the chip manufacturer that invented the LoRa standard is Semtech. And they're based in California, of course. That's where all the smart people live. And they invented a modulation technology that basically is allowing 3 times more range than frequency shift keying. Frequency shift keying is that you just move the frequency of your signal a little bit, and that's how you transfer data. And they use a chirp. A chirp, and I'm trying to explain it, but if I'm not doing a good job, just raise your hands and ask me to repeat my story again. So a chirp is a frequency that goes up. So if I do that, that's a chirp, like you go from a low frequency to a high frequency. And then what you can choose with this technology is the bandwidth and the speed where you change that chirp. So if you want to change, or if you want to send your data fast, then of course you need to do very fast chirps, something like this. So you see that this frequency goes up real fast. But if you want to go long range, then you can do a long chirp, and that means that you get better signal-to-noise ratio, and you can carry that signal further. But it also means that your air time is longer. So you need to make a decision about how do you want to set up your LoRa system. Do you want to do maximum range, or do you want to do maximum data transfer? Yes, question.
Yes, the 30 seconds per day, because it's a community network, and if it was a private network on your vineyard, you can have more than 30 seconds a day?
You can do anything you want. In Europe, it's mandatory. In the US, if you use the Things network as your network provider, it's a fair use policy, but it's not enforced. So if you want to do, like a typical example is if you want to measure how far your range is, then what I typically do is I set up a station to send a signal every 15 seconds. And I put it on the roof of my car, and I drive around, and I take the signal strength while I take the GPS location, and I plot that in the car. I'm going to show you the result later. But that is something that I can do for an hour. And then I used up all my 30 seconds. But nobody's going to flag it like, oh, this guy spent more than 30 seconds. But there will be situations where you get penalized. So there are the Things network has free to use a community network, but companies like Senet, L'Oreal, and recently also Comcast, they have network services that are paid for. And then you're paying for your data. So if you're going over your allotment, then suddenly you'll see that the rates go up.
The other question is so the STAR network.
Yeah.
It's not that all of your sensors are transmitting to your receiver. Your transmitters are sending to a third-party receiver.
Yeah. Let me explain you in the next slide.
Okay. Cool.
I was expecting this question. Yeah. So maybe this explains a little bit how the LoRaWAN system is set up. So here you see nodes, and these nodes all communicate to a gateway, which is here. So in some cases, the stations, the nodes, only can communicate to this gateway because it's within range. In some cases, like this node here, it can communicate to two. So its signal is being received by two gateways at the same time. And the software in the network will decide. So it's not that it will double the network data, but it will basically pick the first station that comes in as the dominant one. From the gateway, you go to an online network server, and the network server basically identifies the station. So the advantage of LoRa or LoRaWAN is that the data is encrypted. So although it's small data, and sometimes you can wonder, like, is the temperature in my home, is that worthwhile the security measures? But LoRa is a two-way communication protocol. So why I wanted the encryption and the security of encryption, because I want to be able to operate irrigation valves. So I don't want you guys to start hacking in my system and start messing with it. Probably you could if you can decrypt the 16-bit encryption key, but it's basically a basic layer of security that is added to it. So if you see how this works, you need to set up a station to connect to the network. So there's this, how you say that, over-the-air activation protocol. That's the first time when the system comes online and it introduces itself to the network. It has an application key, which basically tells the network, I want to talk with this application. And it also has a security key, which is an encryption key, which is shared between the network and the station. So there's a two-way communication. One is that there's secure communication between this node and the network server. And from the network server, because you have an application key which basically points the network server to which application server you want to talk. Is that clear? Does that make sense? Yeah. So what has been the development of LoRa? So it started a few years ago, so it's not that old. This is the result of 3 years of work. A company in Amsterdam started with a wireless solution to detect water leaks in boats. In Amsterdam, they have canals, as you probably know, and the Dutch people, I'm one of them, they like to use their boats during the summer, but during the winter, it's not fun. So we moor them, and then in spring we find that our boats have been floated or half sunk or whatever. So somebody came up with a great idea. Say, why don't we put water detectors in these boats? And then we use a wireless network to connect that to the internet. And if something is leaking in your boat, you get a warning. So that was how the Things network was born 3 years ago. And they basically built 10 gateways, and with the 10 gateways, they covered the whole city. Like, okay, that's pretty cool. So that's what they started with 3 years ago. Now they have 4,000 gateways active all over the world, and you can see the numbers here. And you can also see that at this moment, Europe is way ahead of everybody else with using this technology. We got like about half of the 4,000 gateways are in Europe. Most of the gateways are in the Netherlands, but also Switzerland has a very, very dense network infrastructure already. And then you see it's spreading all over the world. So we can catch up there. So what is Los Angeles looking like? Just to give you an idea. So yeah, we can do something here. There's 2 communities that are active. There's a community in Marina del Rey. So that's the left one, somewhere here. And then there's a community in Los Angeles. So if you want to know more about it, if you want to become involved, there's if you go to the Things network, there's information about where the location of all the communities and who the main contact is for that, and you can basically contact them and sign up, or if you think that you can do better, start your own community, because you can do that too. So this is the status of Los Angeles. So what do you need to get started? So I brought some stuff, show and tell stuff. Yeah. So this is a gateway. I experimented with 5 different brands, and this is the one that I liked best. So this one has been stable, and this is a unit that actually is for the European frequency. So if I want to test a unit for a European customer, and then you can see here I didn't put an antenna on, but a dummy load. So just so it's not radiating at 868, which is illegal here. Yeah. So this is a gateway. And then a soil sensor looks like this. And the good part is, I know I'm running out of time, sorry about that. Yeah, I know, but I'm gonna run out of time. So if you talk about the power of open source and the open source community, this is a good example. So this soil moisture sensor has been in the market for about 30 years. And I contacted that company and I asked them if they would be willing to share with me the calibration data of this unit. And they said, no, that's our IP. We cannot share that. We build our own equipment. They said, yeah, but I'm making an open source system and I would like to use your sensors. So no way. And I tried a couple of times and didn't get anywhere. Yeah, I could sign an NDA, but that would basically defy the whole purpose of being open source. So last week, they finally made the calibration data public domain, which is good. So we as a community, we put a lot of pressure on these guys, saying, hey, we can do the technology better than you. You're good at sensors, and we acknowledge that because we are interested in the sensors. But you know, your technology, your wireless, and your stuff, there's a whole community out there that can do a better job than you. So yeah, they caved in. So that's good. So these sensors connect to a station like this. So this is a little solar panel that we use to charge the battery. And you can probably see here that there's a little battery here. And you see a little module with an antenna. So, let me pull it up. So this is it, guys. That's all. So with this, you can get like 10 miles. Yeah, I'll be happy to pass it along if people want to see it, or if you can come after the presentation, I'll be happy to show you. But this is the radio module that you see here, and what I wanted to show is that when I started with LoRa, I was initially pretty much overwhelmed with all the data that I got. Like I asked a supplier of a LoRa module for data, and they sent me like this big C library, and it was like kilobytes and kilobytes. And I said, what the heck do I need that for? It's like too much for me. I'm not a good programmer, so I admit it. I mean, if you send me 10 pages of C code, I'm going to be overwhelmed, and I just don't know where to start. Yeah, at the top, of course, but so with this, actually, this is the whole setup for the Things network. So it's basically serial data that you send to the module. And you send AT commands. So it's basically a couple of print commands. You send data to that unit, and you configure it for the type of join modes, the duty cycle, and the frequencies you wanted to work on. Remember, I mentioned that Europe has 8 frequencies for LoRa. The US has 64, and a gateway can support 8. So if you use the Things network, you need to pick eight channels from the 64, and ideally you need to figure out which ones the Things network is using, so you are on the same frequency as the network. I found that out the hard way, to be honest. So I couldn't get my system to connect. I could connect to other suppliers, other network providers. I could not connect to the Things network, and I tore my hairs out. And then it turned out to be like a very simple, basic thing. Like I was transmitting at the wrong frequency. So who can come up with that? What kind of standard is that? Well, I found it out, and hopefully, by sharing this, you won't have to go through that again. Any questions so far? Yes, sir.
If you were interested in a private deployment versus like a network that provides it for you,
Yeah.
do you just buy your own equipment, deploy it, and they'll not interfere with each other? Is that at least theoretically?
Yes. Yeah. 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 Is that? Yeah.
That's basically it. Is that you could do your own private deployment?
Yes.
And not.
Yeah, you can build a private network as well if you want that, yes. Yeah, and when you think about the way it's been set up, you can also implement your own network server. So one of the cool things of the Things network is that the code of their network servers is also public domain. So if you want to copy that and build your own network server, you can. So in that sense, it's pretty cool. But there's only so many things you can do.
And what about an implementation in a Latin American country?
Yeah.
I mean, in terms of the signal.
In terms of?
The signal.
Signal. Yeah. Well, it's kind of hard to say because it varies country by country. Like Mexico, for example, uses the same frequencies as the US. Australia uses 925 megahertz, and Europe uses 868 megahertz. So you need to look at the Things network, but also the LoRa standard organization has a country by country frequency list. And I need to warn you that if you buy a gateway, you need to order it for a specific frequency range. So this gateway, for example, is operating at the European frequencies only. I cannot use it in the US because it's just limited in frequency. Is that answering your question? Yeah.
How about noise? Okay. Oh, this you say you need noise, so you actually have reached to 10 miles radius?
Yeah, and noise is so far I haven't had problems with noise. I have problems with hills, and if there's a hill in between, then of course the signal. So you need really line of sight, free line of sight. Yeah. Okay, so I'll if you don't mind, I'll finish unless you have an urgent question. No? Okay, thanks. Yeah. So this is a reading I took from in Temecula. So what you see here is see if I can get the laser to work. Yes. So this is one gateway. Here's another. Here's another. So we got a couple of them, and there's some gateways here, but I haven't mapped them yet. But what you can see is when I drive around in the Temecula area, there's hills, but there's also this road over here, which is the main road in Temecula Wine Country. All the major wineries are there, and you see that we have near continuous coverage there. So anywhere I place a gateway or a station in any of these areas, it will connect to any of these gateways, and often it will connect to multiple of them. So if one gateway loses power or anything, the others take over. So overlapping coverage is actually a good thing here. The gateways with the best range, actually have an external antenna on the roof. So if you use the internal antenna that comes with, or the little rubber antenna that comes with that gateway, and use it indoors, you can get a mile, because just the house attenuates the signal. If you really want to get good range, you need to be on the roof with an external antenna. And keep the antenna cable short, because at 900 megahertz, the cable attenuates as well. So you want to keep it short. So what I typically do is put the gateway in a watertight enclosure on the roof as well. And then with power over Ethernet, power it and get the signal in. So use case, agriculture, of course, in my case. There's other use cases that you can think of, but this is what I use. So we have sensor stations in the vineyard, and they measure temperature, they measure soil moisture using the sensors that I just showed, and they send that data to a gateway over here. So from the gateway, you need to go to an internet router. I use Wi-Fi or Ethernet, and from the internet router you get on the internet, and there's a cloud-based application. So we work with a partner in Europe that made specific applications for vineyards, but now also for orchards. And from that application, you can look at your data, and you can decide, depending on the soil moisture status and the weather data, how long you want to irrigate every day. So the computer basically uses LoRaWAN also to wirelessly activate irrigation valves. So this is an example of an orchard that where we installed systems in Bakersfield, and we installed it mid-April this year. So it's a 13-acre orchard. The 23rd leaf is farmer speak for telling you that the trees are 23 years old. So don't get impressed by that. And then the spacing is such that you get 300 trees per acre. So depending on the season and how hot the weather is, each tree takes about 20 to 65 gallons, sometimes even more water per day. So you can imagine that a vineyard like that or an orchard like that takes a lot of water. And when we installed this, we noticed that the moisture in the soil was actually pretty high. So, to explain this scale, 0 is wet, and the higher the number, the drier it is. So typically you don't want to be higher than 60, And you cannot be wetter than wet. You cannot go negative on this scale. Yeah. So what you see here is we installed it, and we said, hey, this looks pretty wet. And then the farmer said, yeah, but I still need to do the fertigation, which is applying fertilizer to the trees using the irrigation system. So you see a little dip here, and that means that the soil is actually getting wetter. It was already wet, but it was even made worse because the farmer, and you can see that same dip here, the farmer needed to apply fertilizer. And that's the pre-bloom fertilizer, as they call it, and it's a mix of all kind of stuff. And they never tell what it is because it's their secret for growing pistachios. But after that, we said, well, it's still wet. What do we do now? So we got in touch with UCANR, which is the Agricultural Natural Resources group within the UC system. And they have irrigation experts that help farmers. So we asked them, what do we do with this? And he said, well, stop irrigating and then wait till the sensor at 2 feet hits 60. So, okay, we waited. So we waited a month. And so that is the equivalent of eight Olympic swimming pools and water, and just on a 13-acre. Yeah, question, sir?
Yeah, I'm wondering what the irrigation method is that they're using.
Okay, that's a good question. So in vineyards, they typically use drippers, like dripper hoses that you punch in drippers. With these trees, they use little sprayers. So they spray like 3/4 of a radius, and they spray in the area where the root system is. So the roots are pretty shallow, and they use 2 drippers of 6 gallons per hour. So per hour, they basically irrigate 12 gallons. So you can imagine if you want to irrigate 65 gallons, that's you need to irrigate a long time. Yeah. Is that answering your question? Okay. So with that, this is basically nearly the last slide. So it's a free network. It's free to use, and I encourage everybody to, if you are within range of such a network, use it because it's free and it's fun to work with it. If you don't have a network, please consider if that's within what you want to do. Consider putting up a gateway and share it with everybody in your neighborhood. Start a community. Start developing other applications. A lot of applications are things that require long distance. So it's different than Wi-Fi. It's different than Bluetooth, of course. It has its own typical application. But you can imagine, like there was an application where they have mouse traps. So they use this technology to see if you caught a mouse. So you don't. And for some companies that do like a pest control, that's actually a time saver because they don't need to run all these traps or check these traps in the building. They just look on the internet whether they need to check on them trap. And then I talked about the boats, water detection, irrigation, of course, but there's so much more. And that's the part of an open source community. Together we can come up with applications that nobody thought of before. So there are 2 communities here in the area, one in Marina del Rey, one in LA. You're free to start your own community. The Things Network will support you. There's also another thing. There was a big conference in Amsterdam for the first time, and it was a huge success. They held that conference in Amsterdam in February. And although I'm Dutch and I like to visit my family, February is not a good time of year to visit Amsterdam. It's cold, it's nasty, and I didn't like it. And by the way, it was my birthday and I had to celebrate in Amsterdam. Who could think of something worse? But they basically floated this idea of having the conference on tour. But this is a major commitment. So unless a lot of people want to chip in and join, I think it's a good idea to think about, can we do a Things conference in LA or Southern California just to get things started here. They will support it, but it takes a lot of commitment and a lot of effort to make a professional conference. So I'll put a question mark here. But if you want to be personally involved, there's communities, there's a lot of open source software. And I saw this on Amazon last week, which was kind of cool. This is a device that has a microcontroller, it has Bluetooth, it has Wi-Fi, it has LoRa, and it has a little display, and it's $26. And there were people that already said that, yeah, they gave it 5 stars, like we could connect to the Things network. Well, how cool can that be? So, it's easy to get started as long as you have a gateway. And, this is just, to finish it off, this is just a picture that I took of one of the gateways that we installed on the roof. So you see that the antenna is really tiny. And, this is the box where we put that gateway in, so it's protected from the weather and the sun. So with that, I want to show you one last slide, and this is just useful links. So if you want to know more, look at the links first, read the manual, and then call me if you have more questions. All right, we have time for questions? Yeah? Yes, sir.
So what's the difference between LoRa and LoRaWAN?
Yes, it's a very good question. So LoRa is the modulation. It's the lower layer of the protocol. If you use that, then you can get a point-to-point connection where you make a wireless yard. So you put data in one module, and you get data out of the other module, the same data. So it's like a cable, but then without wires. So that's LoRaWAN, or LoRaLAN. And now LoRaWAN uses like the encryption, and you need to use the services. So it's more complicated. So if you want to start developing using a wireless technology, it's actually easier to start with LoRaLAN, because you don't have all the complexity of logging into the network and applying for an account. So it's easier, but if you really want to go to the next level, and I've gone through that process. I want to control valves. I want to be able to control, have multiple stations work at the same time. And with LoRaLAN, I found that if 2 stations are transmitting at the same time, they interfere with each other. And LoRaWAN has taken care of it. And I was thinking, like, should I reinvent the wheel? Well, there is a standard that already takes care of it. So that's
That's great, because I have an application that someone wants to work on. Oh,
Okay.
I'm sorry.
That makes
Yeah,
sense.
so
Clear.
the reason why I asked what the difference between LoRa and LoRaWAN
Yeah.
was because I actually have a customer that's interested in using the LoRa technology, but I couldn't understand the difference between using LoRa, which I think is what they want, because they want point-to-point communication,
Yeah.
versus having the higher level protocol of actually establishing a network, which is, I think, what makes it nice, but that's a different standard. And
Yes.
this is more of to support multiple endpoints.
correct.
Okay,
Correct.
thank you.
There was a question. Sorry.
Oh, yeah. Here,
sorry.
let me
Okay.
make it a little easier so everybody can hear.
Here in Southern California, grass fires are kind of like water and boats in Amsterdam. Happens all the time.
Yeah.
You like to know about it when it happens. If anybody in the room is interested in talking a little bit about using this technology with horizon scanners, which I build, such that if you get one which has a saturated infrared signal, you know the direction and you know the intensity, and then you chirp it up. Come and see me.
Thank you. Yeah, there's actually a lot of use for that. I noticed that this year, especially in Temecula and that area, we had a couple of wildfires, and I've seen the planes fly over my home. So yeah, it's getting close to comfort, to be honest. Yeah, so I appreciate the initiative. Thank you.
Another question? Okay.
Yeah.
I'm coming.
I'm wondering about the liquid sensors. Basically, do you use battery power for them, or do you figure out a way to power them with some local power supply?
I only use battery power at the moment.
Okay.
And the way I achieved it, because if you use an Arduino out of the box, it takes like 19 milliamps at 5 volt. And then I use the Arduino Pro Mini, which is using 8 milliamps. So I found a sketch or library from a company called Rocket Screen. So it allows you to bring the whole system down to a very minimum power state. It doesn't operate, but you can wake it up with an interrupt pin or on a timer, and it basically reduces the currents dramatically. You need to remove the LED though, because the LED takes about 1 milliamp. But we got without any other modifications and the rocker screen, we got from 8 milliamps to 0.5, 0.6 milliamps. And then if we remove some LDOs and other stuff, we get to 60 microamps. So I use two types of batteries. So in this case, I use a rechargeable lithium-ion battery, which is 900 milliamps hour. And then in the case of using a battery only, we use a 9,000 milliamp hour lithium battery, which is a type B form factor. They're about $8. And they can run at 60 microamps, you can run for 10 years.
Oh,
Yeah.
that's pretty good.
Yeah. Well, the thing is, like, that's the theory, right? Like, I hope that battery provides that capacity over 10 years. But that's, what it says according to the specs. So, yeah, we'll talk. We'll come back in 10 years and tell you.
Any other questions? You want the mic?
All right. So feel free to see me after the presentation, or if you have questions, or send me an email, call me, whatever. Thank you.
Thank you so much.